Hi, so this is my video on the law of sines. Now, earlier in this course, we actually learned how to do right angle triangles using saw, quadrant, and the law of sines is actually used when the triangle is not right angled. So the question as to how we actually solve a triangle which is not right angled. So let's take a look at this. So here we have a triangle which is not right angled. The angles are alpha, beta, and gamma, and the angle opposite alpha is the side opposite alpha is A, the side opposite beta is B, and the side opposite gamma is C. All it says is that the sine of the angle alpha and the ratio of that to the side opposite, so sine alpha divided by A, equals the sine of another angle, which is sine beta, divided by the side opposite, which is B, equals sine of gamma divided by C. So sine of alpha divided by the opposite side A, sine of beta divided by the opposite side B, and sine of gamma divided by the opposite of C, and those ratios are equal. So what's the use of that? The use of that is that if you know some of this information, then using this as equations, we can actually grind out the missing information. Now, let me also introduce you to a notation. Um, so, the sign of law can be used to solve the SSA and AAS cases. So, what do you mean by SSA? So, SSA means to solve a triangle where two sides and an angle opposite one of the sides is known. So, look, so what does that mean? So, SS means two sides, and A means an angle, A for angle, right, opposite one of the sides. So if you have a triangle where we know two sides, SS, and an angle opposite one of the sides, you can use the law of sines to solve that angle. You can also use it, right, to solve AAS, right, which is what? A for angle, so two angles and a side. So if we have a triangle where we know two angles and one side, right, that can also be written as ASA. There's not much of a difference. That means there is an angle and a side and an angle, right? Okay, and still two angles. So if you know two angles and a side, we can use the law of sines to solve those cases. Okay, so two sides and an angle opposite one of the sides, or two angles. Alright, so let's look at an example of an ASA or AAS case. Okay. Alright, so look at the triangle in this figure. Alright, so ASA means we know two angles and one side. So do we know two angles here? Yeah, we know this angle and we know this angle. Okay, so two angles there and one side. So how do we know the law size? First of all, it might be a good idea to convert these two angles into degree decimals, because this particular angle is in minutes and degrees. So okay, so this is as it is in degrees. So 28 is one angle, right? And the other angle will be what? 45 plus 20 over 60. If you convert this, so plus 5 by 20 over 60, so we have 45.33. So once you do that, I think we are ready now to solve this triangle. So when we know two angles, the easiest thing to do is to find the third angle. And how do we do that? We know that the angles of a triangle add up to 180. So if you know two angles, we can easily find the third angle, which is gamma, by adding these two angles and subtracting by 180. So what we do is we add the two angles that we know, which is 28 and 45.33, and we subtract it from 180. And when we do that, we get 180 minus 73.33, which is 106.67, and that will be your gamma. So we already know some information now, right? We have managed to do a partial solution. We managed to find gamma, but that's not the end of it. We need to find what? A and B also, because ratios are also missing. So let's try to see whether we can find A. Now how do we know lower the lower signs to find A? So once again, to find A is opposite 28. So we can use that ratio. So we can have sine 28 divided by A is equal to, now we can go to a known ratio. Now because we know gamma, this ratio is known, so is equal to sine, we know that this angle is 106.67, right? So now we can actually say that we know this angle, okay? So because it is 106 point, so we can put a little arrow saying that this angle is now known, right? Okay. So we can say sine 28 over A is equal to sine 106.67 over the side is 120. Sine 28 over A is equal to sine 106.67 over 180. So now we need to solve for A. So in order to solve for A, the easiest thing to do would be to do cross multiply. So if I do it in two steps, you don't have to do it in two steps. So 120, you multiply both sides with 120, and then this 120 goes off, and then you get 120 sine 28 divided by A is equal to sine 106.68. And now we want to multiply both sides with A, and then this A goes off, and then A comes over here, and A sine 106. Okay, so basically we have 120 sine 28 is equal to A sine 106.67, and A is equal to, then you divide, we have to get rid of this part, so A is equal to 120 sine 28 divided by sine 106.67, and you get A as 58.8 meters. Now finally, so we know A, right? So to get this answer, the easiest thing to do would be to just cross multiply. So you multiply this with this, right, is equal to, and then you multiply this with this. That's how you get 120 sine 28 is equal to A sine 106.67. So now finally, so we have now gamma, we solve for gamma, we solve for A, and now we need to solve for B. So how do you solve for B? So we get the ratio involving B, okay? So that will be what? Sine 45.33 after converting to decimals, 45.33 divided by B, right? Opposite side is equal to, you look at the known ratio, which is sine gamma, which is sine 106.67, right? We know this now, right? Okay, divided by 120. Sine 106.67 divided by 120. And now if you cross multiply, we can very easily see that this is equal to 120. So 120 sine 45.33 is equal to B sine 106.67. So I just cross multiplied instead of doing it in two steps. 120 times sine 45.33 is equal to sine 106.67 times B. So B is equal to 120 sine 45.33 divided by sine 106.67, and that goes to 89.1. So B is equal to sine 89. So B is equal to now 89.1. A is equal to 58.8. Okay. So now we pretty much have the triangle. We have B, we have A, we have gamma. Okay. So we have the entire triangle, and then we have solved the triangle. So once again, what we did was we were dealing with the ASA case, when we know two angles and one side. So in that case, the easiest thing is to find the third angle first. We found the third angle, and once we found the third angle, we use that ratio, the known ratio, because then we know this ratio. This ratio is known to find the other side, the two sides A and B. Good. Okay, and then let me also take a look at the second case that we are going to do, the SSA case. The SSA case is a little bit more trickier. Okay, and I will tell you why that is. Okay, so let's look at a case where we have the triangle is A is equal to 47, B is equal to 23, and alpha is equal to 123. So what do we have here? As the name sounds, we know two sides, A and B. So SS, right? But we know only one angle. In the previous case, we knew two angles, but now we know only one angle. Alpha is equal, which is alpha is equal to 123. Now, one thing is that now, first of all, okay, now we already know one ratio, right? Why? Because we know A and alpha. So you might say yes. So we already know one ratio. So let's use that ratio. So we can take sine alpha divided by A, sine alpha divided by A, and look at something unknown. We know beta B, but we do not know beta. So we might want to find beta. So let's first find beta. So what do we have? Sine beta over B is equal to sine alpha over A, right? Okay. And then if you do that, if you cross multiply, right, you will see that A sine beta is equal to B sine alpha. So sine beta is equal to B sine alpha divided by A. So it's or else you can just think of, if you solve for sine beta, you get sine beta is equal to B goes up here, right? If you want to just solve for sine beta, okay, B goes up here, so sine alpha is equal to B sine alpha divided by A. So we plug in, we get B is equal to 23, alpha is equal to 123, and A is equal to 47, right? We get that. Now, what is B? So when we use a calculator, so sine beta is equal to this, so beta is equal to whatever you find this junk using a calculator, right? Okay, and you put the sine inverse and it will give you 24, right? But see, if you remember the unit circle, right? Sine is positive, right? Okay, so if you remember the unit circle, right? Okay, so the sine is positive in two quadrants, right? It is positive in quadrant A and quadrant B. Okay, quadrants 1 and 2. Okay, so if you look at sine beta being this number, okay, there are two angles which actually give this, because there's one angle in quadrant 1 which is 24, where sine is equal to this positive number, but there's another angle in quadrant 2, right? And how do you find that angle? Well, it's very easy to find that angle. All you need to do is to multiply to subtract the original angle by 180. So if you have, say, the quadrant here, and then if you take one small angle which is 24, right? And let me see if I can draw this. So let's put a little quadrant here, right? Okay. So we have this angle which is 24 right here. Now we know that the other angle is its partner, right? I mean, like that. So if you want to find this angle which is 24, if you want to find this angle, what you need to do is to put what? 180, subtract this from 180, and you get the second angle. Now see, when you get two choices for beta, 24 and 156, right? Okay, we can have three situations. The two betas can either give two triangles, right? Or one of the betas can give a triangle and the other one not a triangle, or neither one of these betas can provide a triangle. So you can either have two triangles when you have both betas giving a triangle, or you can have one triangle where one of them will give a triangle while the other will not give a triangle, or we can have zero triangles where neither one of them will actually give a triangle. So once again, what I did was I first found sine beta, and I got one value for beta, okay, and then you subtract that value from 180 and then I get another value for beta. So we need to check whether these two betas actually give triangles, or one of them give triangles, or neither one of them give triangles. What we do is we look at the original given angle, which is alpha, and add the two choices of beta to alpha. So we take alpha and consider alpha plus beta, and we take alpha and we consider alpha plus beta plus, and we say whether those two angles are less than 180. If it is less than 180, that means there is space for a third angle, the gamma angle. Okay, so let me do that first. Okay, so first consider alpha plus beta. So you take your beta. Beta is the first angle, 24. Okay, alpha plus beta, and see what you get. So alpha is 123. The original angle is 123, right? Plus beta is 24, right? Okay, and we get what? 123 plus 24, which is 147, which is definitely less than 180. So definitely in this case we do get a triangle. We do get a triangle, right? So that is fine. But if you look at the other case, when you take alpha and plus beta plus, okay, so beta plus we know now is 156. Alpha remains at 123, so 123 plus 156. We get 279, which is greater than 180, so we do not get a triangle. So we only get one triangle. We don't get two. We don't get zero, but we do get one triangle. And for that one triangle that we get, now we can find gamma just like we did in the previous case, because we know two of the angles, right, alpha and beta. So if we subtract those two angles from 180, so you add them together, 120 plus 24, which is 147. You subtract 180 from 147, you get 33, right? Because the difference between these two is 33, right? And that is your gamma. So gamma is 33 for the triangle. Now for that particular triangle, okay, what do we know? So we know the two sides, right? A and B, and we know alpha, beta, and gamma. So we only need to find C, the remaining side for that triangle, and that we can find by using the ratio sine gamma divided by C equals, right, because we need to find C, so we need to take the sine gamma ratio is equal. You can take any one of the other given ratios. So we can either take sine alpha divided by A or sine beta divided by B, but let's take sine alpha divided by A. Okay, and then we can solve for C and get the answer for C. So a little bit of a long video, okay, but so we just discovered, we just handled only one case in the SSA scenario. Later on we will do the two other cases when we get one triangle. Sorry, we already got the one triangle case, single triangle case, right? But remember, we can get no triangle